In example 4, we are going to learn something different, and we are supposed to solve the equation. We are supposed to solve the modulus of 2x minus 1 modulus is equals to 5. There are several steps in this question, and we are just supposed to solve it in both ways. First of all, we are going to give it a graphical approach, and then we are going to give it an algebraic approach. Let's see. First of all, plot or sketch for that matter, the graph of y is equals 2x minus 1, after which we will reflect along the x-axis because of this part. And what we're going to have is, let's have x and y, normally the way we tabulate them. When x is, let's say, minus 2, y is going to be minus 4 minus 1 minus 5. Of course, we can already modulate at this particular point because we can bring the aspect of modulus y, because it's this which is modulus y, positive 5. When x is 0, we have 2. We have 0 minus 1 minus 1, and modulus of 1 is just 1. When x can be 2, we have 4 minus 1, 3. 3 modulus remains 3. When x is 3, let's see what happens. 6 minus 1, which is a 5, and 5. So we got to have the graph of y is equals to, so minus 1, minus 2, 1, 2, and so on and so forth. 1, 2, 3, 4, 5, 5, 4, 3, 2. This is, let's have it done properly. There is 1, 2, 3, 4, and 5. Minus 1, minus 2, minus 3, minus 4, minus 5. We don't need the negative part of y-axis, so to speak. So when x is negative 2, y is supposed to be 5 when it is moduled. When x is 0, we have a 1. When x is 0, we have a 1. What about when x is at 2? When x is at 2, we have y, which is at 3, somewhere there. When x is at 3, we have a 5. We have a 5 somewhere there. But we don't exactly understand, we don't exactly know at what point does the graph cut the x-axis. So how do we get that? How do we get the point, the vertex of the graph? We can only do that because anything along the x-axis, y is supposed to be equals to 0. So at what point is 2x minus 1 equals to 0? We have to have 2x minus is equals to 1, and x is equals to a half. So when x is equals to a half, then y is supposed to be 0. And that is basically the point of reflection of the graph that is supposed to be that way. So that way we will be able to see this is the reflected part, and this is the original part of the graph. So let us now try to answer the question. Let us try to answer the question. The question is, solve this question. X minus 1 module is equals to 5. We should have two graphs here. The graph of y is equals to 2x minus 1 minus 2x, yes, 2x minus 1 module, and the graph of y is equals to 5, such that when the two graphs intersect, that is now going to give us the solutions of x. And since we have the module part, because this is the graph y is equals 2x minus 1 moduled, we need now to get the graph of y is equals to 5. And this is simply this line. This is knowledge we learned in year 10. This is the line which we can call y is equals to 5. And you can already see the two graphs intersect at this point A and at this point B. The two graphs intersect at point A and at point B. But something special, and very, very special indeed. At point A, the two graphs, y is equals to 5, is meeting y is equals to 2x minus 1 modulus in the moduled region. In the moduled region. The moduled region means it was originally supposed to be negative. It's supposed to be giving us negative values of y. Part B, the y is equals to 5 is meeting y is equals to module 2x minus 1 in the original part. That means it was originally, or rather the values of y in all this part were originally positive. So how do we go about solving it? It is in two parts. Number one, we have to talk about y, and this is the second approach now. We have to talk about let, and we are now dealing with part B. Let 2x minus 1, which is supposed to be positive, be equals to 5. Therefore, 2x is equals to 6, and x is supposed to be equals to 3. At this particular point, and you can see this particular point, the value of x is 3, and the value of y is 5. So you can already, in fact, give those coordinates 3, 5. The most interesting part is part A. When we are solving part A, how do we solve part A? Part A is as a result of moduled function. And moduled function means let now the negative part of 2x minus 1 be equals to 5. And what is this negative part? Open the bracket and have negative 2x plus 1 is equals to 5. And negative 2x is equals to 4. Divide by negative 2, divide by negative 2 both sides, and you realize that x is supposed to be negative 2. And sure enough, when you get to the graph, you get the coordinates of this particular point, minus 2, 5. So, in summary, when we have 2x minus 1 module to be equals to 5, you will get this relationship at x is equals to minus 2 and at x is equals to positive 3. And those are the solutions of this particular relationship. All right?